for problem 13 from section 1-2, we're asked to do a couple of things here. We're asked to sketch the direction field, identify a constant or an equilibrium solution, and then determine the stability. Now, recall a constant solution is in fact the same thing as an equilibrium solution, so we're not really distinguishing. So it's not find a constant one or an equilibrium one, but find a quote-unquote constant or equilibrium solution, whatever you want to call it. And so what we're going to look at here is the equation y prime equals 1 minus y. A couple good things to recognize here is that there is no t involved in this, right? And so when we start graphing, t is going to be our horizontal line. And since there is none, or a horizontal axis, our idea is that the direction field, it seems like the directions won't rely on t, right? So if it's at the same altitude or the same height, then everything along that height should have the same slope. Since as you say move from left to right, the t is not changing the value of the derivative of y prime. So that's something that I'm expecting. But to do this, we can figure it out. So what I'm going to do first is actually find those constant solutions or those equilibriums, and then sketch the direction field around that. So the way to do that is we think the constants is when your derivative is equal to 0, right? So in other words, when is 1 minus y equal to 0? Well, that happens exactly when y is equal to 1. So this is our equilibrium. So if we stick some units on this, we can say, well, where you have the height 1, that's where we get this y equals 1 is some sort of equilibrium solution. So it's a horizontal line. Now what I'm going to do is I'm going to think, well, what else can I say? Well, let's find now the direction field to see if this is a stable equilibrium or an unstable. Right? So a stable equilibrium, you might imagine something like a marble in a bowl, right? Where the equilibrium is at the bottom, everything, if you drop a marble in there, it'll roll towards the bottom of the bowl, right? So there it's a stable equilibrium. Unstable is a place where it rests, right? So a solution right on this line will stay on this line. But if you push it off a little bit, it might go away from it. So it's like a marble on top of a hill or marble on top of a upside down bowl, right? Where it's balanced. But if you push it off just a little bit, it will tend away. So let's find out the stability. So in order to do this, I'm going to plot the direction field. So let's set y prime equal to some different values in order to get our isoclines. So let's think if y prime was equal to something like 1, right? Let's take some easy numbers. That's the same thing as saying 1 minus y is equal to 1, or to solve this, y would be 0. So this right here is an isocline with slope 1. So that tells you, maybe I'll do this in a different color, I'll do this and say yellow. So along the line y equals 0, we have a slope of 1. So our isocline is right here. Let's find some other values. If y, let's do this, why don't we go ahead and stick with this theme of changing color. So y prime, let's say it was equal to 2. That'd be saying 1 minus y is equal to 2. Or in other words, y would have to be, in this case, it would have to be, we say negative 1. So this tells you, well, where does this isocline, right, with the slope of 2, where does it live, right? Where is it at? Well, it's at along the line y equals negative 1, which is right here. So slope of 2, which is a little bit steeper, goes along this line, y equals negative 1. So we sort of see that's going to happen. As you get deeper, it's going to keep increasing, all right, in slope. And then, well, what if we took a point of where you want to have a negative slope for your isocline. So let's say -1. Well, that tells you, oh, I should have, let's back that up. Let's use a different color here. Yeah, so where does it have a slope of -1? Well, that's when 1 minus y is equal to -1. Or you can say that's along the line y equals 2. So this is the isocline, is a line y equals 2. And that has a slope along it of -1. So up here we have a slope of -1, like so. And so we see any y value, if y is greater than 1, we're going to have a negative slope. If y is less than 1, we're going to have a positive slope. So this gives me a sense of the direction field right here. Now if I want to draw some solutions into there, let's go ahead and do some solutions in, let's just put them in black. So these are the isoclines, sort of the lines along which there's a constant slope, which is different than a constant solution, because the constant solution is when the slope's 0. And so if I had a point right along that constant solution, oh, that's bad. Let's do it this way. It would stay along there. So that sort of black line, that is a solution. But anything, if I drop a point up here, it's going to tend towards this. Drop a point down here, it will tend towards it as well. And so we see as time increases to the right, all solutions are tending towards this constant solution. So what that means is that it is stable. So this solution is stable. Great.